So Unit 5 dealt with our multiplication rules, also referred to as our AND probabilities. For example, probability of event A and event B. This unit, however, we're going to be focusing on the probability of event A or event B. And we're going to be looking at addition rules. So keep in mind, AND means to multiply, or means to add. Now, last unit, we were doing two or more events. And in those situations, the events could be independent, meaning that the probability of one does not affect the probability of the other, or dependent, meaning that it does affect it. However, in this unit, we are only doing one event, but multiple options. And that is actually called mutually exclusive. Mutually exclusive is two or more events that cannot happen at the same time. In other words, rolling a die and getting an even number or getting a 3. 3 is not an even number, so that would be mutually exclusive. In that case, if they are mutually exclusive, you would just add the two probabilities. The probability of it being even plus the probability of it being a 3. However, it could also be not mutually exclusive. So going back to the rolling a die, we could say our event A is rolling an odd number, and then B is, let's say, multiple of 3. In this case, our odd numbers are 1, 3, and 5. Multiples of 3 would be 3 and a 6. Well, I said 3 twice. So 1, 5, and 3 are in my odd circle, but 3 and 6 are in my multiple of 3 circle. And because we have this overlap, that 3 is in both categories, it is not mutually exclusive. So what we have to do is find the probability of A, it being odd, plus find the probability of B, it being a multiple of 3, minus the probability of A and B, aka what I like to call sometimes our overlap. So let's look at an example 1. We decide to roll a fair 6-sided dice twice. Note all 3 of these problems, A, B, and C, say or, so that tells us we're going to have to add. First is the probability of 5 or a 3. Now, I know that these events are mutually exclusive because it cannot be a 5 or a 3 at the same time. So that tells me that I just need to add. Probability of a 5 would be a 1 out of 6. Or means to add. Probability of 3 would be a 1 out of 6. And to add fractions, the bottom number or the denominator has to be the same number. It is, so we just add the tops. The 1 plus 1 is 2 out of 6. In B, probability of even or a 1. Is this mutually exclusive? Yes, it is. Because a 1 is an odd number and cannot happen at the same time as an even. So probability of an even, well, there are three options, a 2, 4, and a 6, out of my 6 sides, plus probability of a 1, there's 1 out of 6. My denominator or bottom number is the same, so I'm going to add across. 1 plus 3 is 4 out of 6. And then C, odd or 5. Is this mutually exclusive? No, it is not. Because if we rolled a 5, that is a 5 and an odd number. So we are going to need to subtract that overlap. So, starting the problem off the same. Probability of an odd would be 3 out of 6. Plus the probability of it being a 5 would be 1 out of 6. Minus my overlap. So how many numbers are in my overlap? Well, it would be the 1 out of 6. So 3 plus 1 is 4, minus 1 is 3. Let's look at the next example. Example 2. Students at a local high school were randomly sorted into 3 different groups as shown below. Notice on how it just has a total of students in it, but it doesn't have our totals. So take a moment and find out the total for group A, B, C, our freshmen, sophomore, juniors, and seniors, and our grand total. Okay, I have my totals in. So our first question is probability of group A or a junior. So sometimes I like to kind of highlight the rows I'm talking about. Group A or a junior. So is this mutually exclusive? Meaning, did I make an overlap? Yes, I did. So I'm going to have to subtract. So probability of group A, well, how many total people were in group A? Well, there were 1,200 out of 3,146. Or means to add juniors. Well, there were 776 juniors out of the 3,146. But my overlap, how many juniors were in group A? Well, that was our 257 out of 3,146. All of our denominators are the same. So we're going to take 1,200 plus 776 minus 257, get 1,719. Okay, second one. Probability of a senior or a freshman. So let's see if there is an overlap. So, senior or freshman. Did I have an overlap? No, I did not. And if we think about it, you can't be both a senior and a freshman at the same time. So this one is mutually exclusive. So seniors, we had 1,004 seniors out of 3,146. Plus, we had 640 freshmen out of 3,146. I'm not subtracting because they are mutually exclusive. I am going to add across them. So I should get 1,644. Go ahead and try probability in number C, or letter C. Probability of a sophomore or group C. So we have sophomores and we have group C. In this one, we do have an overlap, so it is not mutually exclusive. So probability of a sophomore is 726 out of 3,146. Plus probability of group C is 980 out of 3,146. Minus my overlap of 312 out of 3,146. For a grand total of 1,394 out of 3,106. In example 3, there are two of them. So in order to do these probabilities, when we have a Venn diagram, I want to know the total in each circle. So my total in A, 9 plus 12, is 21. So I know there's 21 total in group A. 9 plus 15 would be 24 in group B. And I like to make a side note of that. Makes doing these probabilities a lot easier. So A wants probability of, well, A. There are 21 out of, if I add all three numbers, I know my total is 6. It'll be 12, not 21. It is 21. I know. 21 out of 36. Part B says and. So we're looking at just the middle, just our overlap, our football shape. So that would be 9 out of 36. And then C, probability of A or B. These two circles, this Venn diagram does have an overlap, so we will have to subtract because it is not mutually exclusive. So probability of A would be 21 out of 36, plus B, which is 24 out of 36, minus our overlap of 9 out of 36. If we add across and then subtract, we get, well, 21 plus 24 minus 9 gives us 36 out of 36. And if we think about it, according to this problem, are there any other options besides A or B? No. So 36 over 36 is just 1. And that even confirms that there are no other options. So let's look at the second bit. The second one, we have more than one circle. Actually, more than two. We have A, B, and C. So if we look at everything that is in circle A, those numbers are 6, 14, 10, and 7. Meaning our total for A is 37. Everything in circle B. Well, that would be 14, 10, 5, and an 8. Our total here also so happens to be 37. And then everything in circle C is a 7, 10, 12, and a 5 for a total of 34. And then if I add up all of these individual numbers, 6, 14, 8, 7, 10, 5, and 12, I get a total of 62. Okay. For A, probability of A or B. Well, all of these have an overlap, so all of these are not mutually exclusive. So for A, probability of A would be 37 out of 62. Or means to add, probability of B would be 37 out of 62. Minus my overlap. So overlap between my red and purple circles are 14 and 10. 14 plus 10 gets me 24, so it's minus 24 out of 62. 37 plus 37 minus 24 gets me 50 out of 62. That's my final probability. B wants probability of A or C this time. So the purple circle and the green circle. So probability of A, 37 out of 62. Plus the probability of C, 34 out of 62. Minus my overlap. Overlap between the purple and green circles are the 10 and 7. So 17 out of 62. Gets 54 out of 62. Try doing part C. Part C says probability of B or C. Well, the probability, aka our red or green circles. Probability of B would be 37 out of 62. Plus probability of C, so 34 out of 62. Minus my overlap of those two colors, so 10 and a 5, to get me a total of 15 out of 62. Equals 56 out of 62. Or 62. And if we take a moment to look at our last one, it says probability of A or B or C. So we can do 37 out of 62 plus 37 out of 62 plus 34 out of 62 minus 17 out of 62 minus 15 out of 62 minus 24 out of 62. And we'll get the same answer. Or we could also think, are there any other options besides A, B, and C? There isn't. So our answer should be 62 out of 62 or a 1.